Okay, this is page 75 of Note Spiral. And this is an FRQ on complement scenarios. And I think this is one of the more challenging complement scenarios I've seen on an AP exam. So, two antibiotics are available as treatment for a common ear infection in children. Antibiotic A is known to effectively cure the infection 60% of the time. All right, so antibiotic A works 60% of the time. I'm going to go ahead and make a little note to myself that it means it fails 40% of the time, or 0.40. Okay, treatment with antibiotic A costs $50. Antibiotic B is known to effectively cure the infection 90% of the time. Well, if it cures 90% of the time, it fails 10% of the time. Make a little note of myself. And it costs $80. The two antibiotics work independently. This is key. They're telling me this because they're saying, hey, we can multiply the probabilities if we need to, right? Independent means I can multiply them at the end. So both antibiotics can be safely administered to children. A health insurance company intends to recommend one of the following plans for treatment with children with this ear infection. So plan one, treat with antibiotic A. If it's not effective, then with antibiotic B. Plan two, treat with antibiotic B first. If it's not effective, then treat with antibiotic A. So, if a doctor treats a child with an ear infection using plan one, what's the probability the child will be cured? So let's look at this. We have plan one. And with plan one, the very first thing we're going to do is we'll go, okay, we're going to use antibiotic A. And antibiotic A has a 60% chance of success. But what if it fails? Well, how often does it fail? It fails 40% of the time. And if it fails, then we're going to go to B. And the probability of B is successful is 0.90. All right, so this is drug A, this is drug B, and this is A fail. So 0.6 plus 0.36, so there's a 0.96 chance of getting cured with plan one. Plan two. All right, now we're starting with drug B. Well, drug B has a 90% chance of success. But we know it sometimes fails. It fails 10% of the time. So this is a B fail. And we know that drug A has a 60% chance of success. And when we multiply them out, we end up getting 0.96. So the cure rates are equal. Compute the expected cost per child when plan one is used for treatment. All right, so plan one. We know plan one is working in this way. All right, so plan one works this way. So we know there's a 100% chance that we're going to spend the $50 because we're buying drug A regardless. We're buying drug A regardless. But there's a 40% chance that we have an A fail. And if I do that, I'm going to have to go spend the $80 for drug B. And when I do that, I end up getting that this cost $82. I should have labeled this plan one. When I go to plan two, We're going to start off with drug B, and drug B costs $80. But if we have a B fail, which happens 10% of the time, then we're going to have to go spend the $50 on drug A. And this means this cost me $85, which is $3 more. So, based on the results in part A and B, which plan would you would I choose? Well, because both treatment protocols have the same cure rate, I would choose plan 1 because it is $3 less than plan 2. I want to minimize the costs. All right. All right. Before I stop the recording, you probably should look at that one in the note spiral as I give a more complete set of steps. But that is how you do it, and that is the thought process.